Welcome to this session, and here we shall discuss about multiple angles and sub-multiple angles. That is trigonometry of multiple angles and sub-multiple angles. These multiple angles involve double angles and sub-multiple are half angles. Now let us quickly see the important formulas involved. Say sine 2 theta is equal to 2 sine theta cos theta. Similarly, cos 2 theta is equal to cos square theta minus sin square theta. This can also be expressed as twice of cos square theta minus 1 and 1 minus twice of sin square theta. Note that this cos 2 theta is expressible in three different forms. Therefore, it becomes little bit critical and important because according to the question we have to decide which form is to be used. Now next, tan 2 theta, it is simple tan twice of tan theta upon 1 minus tan square theta. So these are three fundamental or basic formulas for multiple angles, or you can call them double angle. They are double angle. Similarly, we can have triple angles also and multiple angles. Now let us see half angles. Half angle. Let me just put it this way. Now, from this identity, from this very second identity, this is very, very important, I told you. From here we have sine square theta is just making use of this 1 minus cos of 2 theta divided by 2. Now if I just half this theta, that means sine of theta by 2, because this is square, I am taking the square root, plus or minus under root of 1 minus cos 2 theta. Since it was theta, I wrote theta by 2. Now it is 2 theta, I just write theta upon 2. So this is my expression for sine theta by 2, that is sine of half angle. Similarly, cos theta by 2 can be written as plus or minus under root of 1 plus cos theta by 2. The explanation is same as how I did for sine square. For this we will take this relation. And now for tan theta by 2, which is very simple, as we know tan theta is nothing but sine theta by cos theta. We will take the division of these two, which is plus or minus of 1 minus cos theta upon 1 plus cos theta. So these are the basic half angle formulae. Now let us see this formula little bit in detail. Tan theta by 2 is plus or minus 1 minus cos theta upon 1 plus cos theta. This is what we have from above. Now if I multiply numerator and denominator by under root of 1 plus cos theta and 1 plus cos theta. I have multiplied and divided. That is without making any change because this cancels, it's 1. So this will become plus or minus under root of 1 minus cos theta times 1 plus cos theta, and in denominator we will have 1 plus cos theta the whole square. Now here we will make use of the identity a minus b into a plus b, which is nothing but a square minus b square. That is 1 minus cos square theta upon, this remains as it is, cos theta the whole square. Now this can be further written as, because we know from Pythagorean identity 1 minus cos square theta is nothing but sin square theta, denominator as it is cos theta the whole square, and entire thing is under radical. Now remove radical, sin square theta will become sin theta, and this is 1 plus cos theta. So this is another expression for tan theta by 2. And on similar lines, we can also express tan theta by 2 as plus or minus 1 minus cos theta upon sin theta. Now we have this one important formula for tan theta by 2, and this is another way of expressing tan theta by 2, and this is another way. So we have to be very careful. According to the problem, we should be using this. Now let us quickly practice few questions. Now let me take first few questions from double angle problems on double angle. Let me take the first problem. If cos theta is 12 on 13, find sin 2 theta. Let's see the solution. We know sin 2 theta is twice of sin theta times cos theta. That is, sin 2 theta is twice of under root of 1 minus cos square theta times cos theta, because sin theta can be written as 1 minus cos square theta under root. This becomes twice. Now put the values, 1 minus 12 upon 13 square times 12 upon 13. This will become 1 minus 144, the square of 12. Square of 13 is 169 multiplied by 12 upon 13. Next step, 2 times of, let is denominator is 169. It is 169 minus 144 times 12 upon 13, which will give us twice of this subtracted from this is 25 upon 169 into 12 upon 13. this will become 2 times of 5 upon 13 multiplied by 12 upon 13, which is 120 upon 169. This is our final answer. So we have to be very careful while using these identities. Let us see another question. Question number 2. Find tan theta. Find tan 2 theta if tan theta is 2. Let's see the solution. We know tan 2 theta is twice of tan theta upon 1 minus tan square theta. Just put the values. Twice of tan 2 theta is 2. 1 minus square of 2, which is 4 upon minus 3, or minus of 4 on 3. This is our answer. This was a very simple question. Let me take another question. Question number 3. Find cos 2 theta if sin theta is 8 upon 17 and theta is in first quadrant. Now, solution we will see. We have cos theta. Say sine. Let us take sine theta by 2. Sorry. We have to find cos 2 theta. So we have cos 2 theta is 1 minus twice of sine square theta. It's a simple question. Just put the values. 1 minus twice of 8 on 17 square, which is 1 minus twice of 64 upon 289. This gives you 1 minus 128 upon 289. Denominator remains 289. This is 289 minus 128, which is, we will subtract 289 minus 128, that is 161 on 289. This is our final answer. So, based on double angle questions, you will get these type of questions. Now let us take few questions from half angles. Now, practice problems on half angles. Let me take the first question. If cos theta is 3 by 5, find sin theta by 2 for 0 less than equal to theta less than equal to pi. Now solution, let's see solution. We have, from formula we have sine theta by 2 is plus or minus under root of 1 minus cos theta upon 2. Let me just put the values because I know cos theta is 3 by 5. I'll put those values here. 1 minus 3 by 5 on 2, and we will simplify this as plus or minus 5 minus 3 by 5, and this is in denominator, so multiply. This gives us plus or minus 2 upon 5 multiplied by 2. 2 cancels. We are left with plus or minus under root of 1 by 5 or plus or minus 1 on root 5. Now, point to be noted, since 0 is less than equal to theta is less than equal to phi, we take positive root. Now, as it is in first and second quadrant, in first and second quadrant, we have sign positive, so this will be positive. Sine theta by 2 is 1 on root 5, positive value. This is our final answer. Let us take quickly another question. If cos theta by 2 is 2 upon 3, now find tan theta. It's quite similar to the previous one. Let us see how to proceed with it. We know cos theta by 2 is plus or minus root of 1 plus cos theta by 2. In the previous question, we were to find out sin theta by 2. Now here cos theta by 2 is given and we are to find out tan theta. Now this cos theta by 2 is given to be equal to 2 by 3. Now let me just square both sides. So what I am going to get? 1 plus cos theta by 2 is equal to 2 on 3 square, which is 4 on 9. Now rearranging, we will get cos theta is equal to 4 times 2 by 9 minus 1, which is 8 minus 9 upon 9, or cos theta is minus 1 upon 9. We will, important information will be used, so that we put it in a box. Now, using Pythagorean identity, I know sin square theta is 1 minus cos square theta. This is your Pythagorean identity. Now, cos theta, the value we have got 1 minus of minus 1 by 9 square, which is 1 minus 1 by 81, and this becomes 81 minus 1 by 81, or Sin theta I get plus or minus under root of 80 upon 81. This is again another important value, right? Or this can further be written as plus or minus 16 fives are, so 4 root 5 on 9. So this is this. Now important point is to be noted that since cos theta by 2 is positive, it implies that theta by 2 is in first quadrant. So theta will be in first or fourth quadrant. This point is important. You must understand this. What is the reason for this? And also, cos theta is minus 1 by 9, which is negative. Implies that theta must be in fourth quadrant, where sign is negative. So sin theta is minus 4 root 5 on 9. Now, finally we will have tan theta equals to sin theta by cos theta. This is what we know from the beginning. And sin theta, the value of sin theta is, I have minus 4 times root 5 on 9, and cos theta, the value of cos theta is minus 1 on 9. This 9 and this 9 will cancel. Minus and minus will cancel. We are left with just 4 root 5, and this is our final answer. Now see, this question is important and you should understand the various steps of this question clearly, because about the sign concept usually the students make mistake. Now let me take another question. Question number 3. Given sin theta is minus 3 on 5 and theta is in third quadrant, we have to find now sin theta by 2 and cos theta by 2. Let's quickly take the solution. We know that cos theta is root of 1 minus sin square theta. This we are getting from Pythagorean identity. So this gives, now putting those values, we will have cos theta under root of 1 minus of minus 3 by 5 square. This will become root of 1 minus 9 on 25 and that is under root of 25 minus 9 upon 25, which is root of 16 on 25, and that is plus 4 by 5 plus or minus. These are all plus or minus because they are the square root. Now we will take minus 4 by 5 as theta is in third quadrant and cos in third quadrant will be negative. Now sin theta by 2 is plus or minus of root of 1 minus cos theta by 2. Now we got the cos theta by 2, cos theta's value. We will put that here, which is plus or minus under root of 1 minus of minus 4 by 5 on 2. And this becomes plus or minus under root of 1 plus 4 on 5 by 2, which becomes plus or minus 5 plus 4 on 5 multiplied by 2. This is 9 on 10 under root plus or minus. Or this can be written as plus or minus 3 root 10. So I got sin theta by 2. This value we will just put it in a box. It is important. Now we will find out the cos using the same formula, and cos theta by 2 is plus or minus root over of 1 plus cos theta by 2. I'll put the values plus minus under root of 1 plus minus of 4 on 5 upon 2. This will give plus or minus root over of 5 minus 4, 5 times 2, which is plus or minus 1 on root 10. Now I got cos theta by 2 as plus or minus the root of 1 on 10. This is another important information. Now note, since theta is in third quadrant, it is given that theta is in third quadrant, will imply theta by 2 is in second quadrant, where we know that sine is positive and cosine is negative. So sine theta by 2 is 3 on root 10. Sine is positive, and cos theta by 2 is going to be minus 1 on root 10. This is our final answer. So this way you can practice a number of questions based on this. Now I would really appreciate if you try few questions which are this. Just take these questions and practice. From this, the first 5 questions are based on your multiple angles, and these are based on your half angles. Any question you find difficulty, please write it in comment. I'll certainly help you solving and explain your doubt. Thank you very much and have a nice time.